Number one, so anytime you have a fraction equal to a fraction, we must cross multiply. So that's what we've done so far. Now we need to multiply this out. Some of you will use the box, some of you will use some other method. Maybe you can do it in your head. If so, great, but let's just jump right in. Take 30 seconds, then I'll unfreeze it to multiply this out, the right side of the equation. Guys, we shouldn't hear any talking, right? Go ahead and ensure you're getting this done. And the hope is, right, when you do this, you get something like this, right? Again, look up if you have finished it to ensure that you got it. Yep. Because the x is inside the argument, so you're multiplying sine of x times sine of x. So it's sine squared, but the x is inside the argument, so you do not square what is inside. Question. So now we got to isolate the variable. You all can do that on your own. Take a minute, I'll unfreeze it. So isolate the variable. If you have a question, let me know. I hope most people got to this step in the first step. So continue isolating the variable. So we get here. We hope most people can get here without a hitch. Now you need to, the hint is get rid of this. So figure out a way to get rid of the square root. Think about if you had x squared, how would you get rid of that square root? Do the same exact thing here. So figure out a way to get rid of the square root. And we hope you end up with always has to be plus or minus when you take a square root, absolutely. Any questions on this? Some of you will recognize right away from your square root rules that this is the same as this. The plus or minus can go wherever you would like it to go, but just not at both spots. It can go on the top or the bottom. Right, and let's continue going from here. So you all can do this and get this. And now we need to split this up into two equations, because this is really two equations. Right? This is really, here's one equation. And here's the second equation. Two equations. Let's take questions here, and if you're good with this, solve these equations on the unit circle. But I'll wait to solve them to see if there are questions and to give you all a chance to solve. So we're looking for where on the unit circle will sine of x be root 3 over 2. You're thinking that sine is positive in quadrants 1 and 2. So it's x equals some number. Figure out those angles out. I'll start with positive side. Sine of x equals root 3 over 2. Right? Some of you all have already gotten that. That is great. But you should get, so please verify that you get this. And now, once you've gotten that, let's go to the negative side. So let's take care of that. Take 25 seconds. Sine of x equals negative root 3 over 2. Again, quadrants 3 and 4 this time. Again, you'll have two answers. And those two answers are the following. Again, look up once you've completed it, obviously. Give yourself an opportunity to practice. So we have 1, 2, 3, 4 answers. questions? So now we're not done because it says to go from negative infinity to infinity. So let's all add what we should add because we're going from negative infinity to infinity, and then write the actual final answer. So remember, we're going negative infinity to infinity, so therefore you need to add something. You all know what to add. Please make sure you write your answer correctly. Thank you, Chepe. I appreciate it.
Oh, she said, yeah, don't ask for passes. I always get it messed up, so.
Thank you. So here's our answer. So let me take questions on this before we go to problem 5. Chepe. Number 1. Totally.
Besides those, pi over 3 and 2 pi over 3 also as an answer.
No. This is the answer. Like, these are the answers. Like, not those other ones. Those other ones were just this piece, but the domain restriction is from negative infinity to infinity. So by writing this, you also capture those original ones. Because if k is 0, then these all go away, and then you just have these 4 original answers. So let me take questions on number 1. Did I hear a question? Okay. Let's go to number 5. So number 5 says 4 sine x cosine x plus 2 sine x minus 2. I will unfreeze in 1 second. Such a mistake.
Number 5?
Number 5, yeah. Here we are. And just please note we changed the domain restriction here to negative 4 pi to 4 pi. Please note. So when I look at this, there's a slight problem. I can't cross multiply. I don't have a fraction equal to a fraction. I can't combine fractions. There are no fractions here. I can't use a quadratic because there's no squared terms. So I have to use another strategy that you all learned with Mr. Kurth and we touched on last semester. It's called factoring by grouping. By grouping. Do you guys remember? Anybody remember hearing that strategy before? Okay, a little bit. Good. I'm totally about to, bro. It's very funny in the last class. So this guy, he was like, something. He's like, "Do you guys know how to do this?" And Janaea was like, "I'll do an example, then we'll check it through." Like, all right, here we go. Game on. Okay, so factoring by grouping is the following. It says, look, take these two terms. By the way, a term is just one set of numbers that are multiplied together, basically. So we have two terms here, term 1, term 2. Terms are separated by an addition sign or a subtraction sign. So think of this as a sentence, period, new sentence. Factoring by grouping says take these two terms that are next to each other and look at what is common, or what do they both have. So they both have a sign, and they both have at least 1, 2. This one happens to be 2 times 2, but they both have 1, 2, and 1 sign. So you factor that out. So the 2 comes out, and the sign comes out. And what are we left with? Well, what is left here? If I take out a 2 and a sign, I'm left with 1, 2 from here, and the cosine. If I take out a 2 and a sign from here, I'm left with 1. And by take out, I kind of mean divide. Factoring is division. Put it in quotes. So you're right, you can't divide, so I'm not dividing because I still have it here. Dividing would be just getting rid of this. So factoring, but the way to think about factoring is I am dividing these terms by 2 sine of x. I'm just keeping it out here. Now we look at these two terms here, and I say, what do these have in common? Well, unfortunately, they both don't have cosine, so I can't do that. They both don't have a 2. The only thing they both have is a negative 1. Both sides have a negative sign. So let's take that negative out. So negative 1, if we take out this negative, what is left? 2 cosine of x. And negative 1, what is left here? Just positive 1. And the way you can check your work is, if I were to distribute these things outside to this, I should get this. So 2 sine x times 2 cos x is 4 sine x cos x. 2 sine x times 1 is 2 sine x. Negative 1 times 2 cos x is negative 2 cos x, and negative 1 times 1 is negative 1. Questions on that? Edgar, are you sure you don't have a question? I'm worried about your facial expression right now. Okay. So the next step is, now we have 2 terms. 1 term, 2 terms. So we need to do the same process again. Looking at these 2 terms, what do they have in common? Well, they both have the same bracketed part. So take that bracketed part outside. Factor that out. So outside you have the 2 cosine of x plus 1. In the other class, somebody asked what's the difference between brackets and parentheses. Absolutely nothing. That's a really good song, whoever said that. Now, so what is left here? Well, 2 sine x and what is left here? Minus 1. Absolutely. So what has happened is, well, we said if I multiply this bracket times this, what do I get? I get this. Bracket times 2 sine x. If I multiply this bracket times negative 1, what do I get? The bracket times negative 1. This is a strategy of factoring by grouping. And the reason this is so helpful is because now all I need to do is write this. We need to split each piece and set each piece equal to 0. I'll give you 2 minutes on that. Split each piece, set it equal to 0. Solve for x in both cases. Questions? So in other words, we want to solve these 2 equations. We want to solve these 2 equations. So I'm going to solve the one with the plus 1 first, then I'm going to go to the negative 1. So I hope you got to this step. Now you want to find what angles have a cosine of negative 1/2. In other words, what angles can I plug in here that have a cosine of negative 1/2? So go ahead and think about that. We'll unfreeze in about 20 seconds, but you're thinking about what angle has a cosine of negative 1/2. You're thinking I'm